Wood and the Parabole.ai team. These guys presented at one of our staff meetings recently, pretty compelling use cases and done some very interesting work. And so really excited to get them here for the Estes Park group, both for everybody that's live and those that'll catch the recording here afterwards. So Mark's promised an interactive session, so I'll help keep an eye on the hands as they might go up, but feel free to get involved. And with that, Mark, I'm going to just let you take it away.
Sure, thank you. There's still a couple of people joining here. So we'll go ahead and introduce ourselves. So I'm Mark Wood. I'm actually the lead for Parabole in EMEA. And we've got JD with us here. So Jonathan Doan actually heads up global sales for Parabole in the US. And he's going to be walking through the presentation today. For the session, because it's a decent size audience, but what we like to do is we like to keep it as interactive as possible. So do put your hands up at any point during the presentation. We'll pause, we'll answer questions rather than leave it to the end, because I tend to find that you leave it to the end, you run out of time. So I'd rather, that we pick up questions as we go through. So don't be afraid to put your hands up. And anyway, with that, I will hand over to JD from now on.
From now on. Nice to meet you all. I'm Jonathan Doan. As Mark said, I run sales for Parabole. I've been engaged in Graph since about 2015 when I ran sales for Stardog. And I've known Dave and the team for that same amount of time. We've been fortunate to work with some of the largest customers in the world. Probably some of them, we worked on some of them together. And one of our partners, Parabole, came to my attention back in 2016, 2017. And after a short stint over at Oxford working for a machine learning company, I decided to come over to Parabole and run sales for them. They had a couple of early use cases that got me really excited. I'm going to share a couple of those today. And it's also been interesting that with the advent or newfound popularity of Gen AI and LLMs, that there's an interesting cross-section to talk about there as well. So I'll dive in. I've got not too many slides, and hopefully a little bit more focused on the use cases and how we're helping our customers and our partners. So let me share this slide real quick. You see my screen, Mark?
Yeah, it's come through.
Okay, good. So at its most basic, I'm gonna come back and sort of probably start before this slide with the next deck. But at its most basic, what we're trying to do is help our largest clients, regardless of vertical, regardless of application they're trying to create very rich causal models, very rich domain models to support causal models and causal modeling and decision intelligence, using a machine teaching capability that our company has innovated. The company's been around for about 6 years. I think that we struggled in a couple of verticals early on, and a manufacturing client came to us about 3 years ago with a couple of interesting problems, and I'm going to talk through that couple of those use cases in a second. But essentially what we're doing is building out a larger domain model of the world that represents your problem. So let's just say, for sake of interest, supply chain or drug discovery. So we bring in much like Gen AI would, we bring in domain models representing that domain. We bring in your own data, your own models, your own processes. The term that I like to use for this is digital mirror. Digital twin to me isn't all encompassing enough, because digital twin is more, to me, more machine shop focused, more focused on the very specific manufacturing processes of organizations, as opposed to a digital mirror, which to me is all of your people, all of your capabilities, customers, products, raw materials, really plants, locations, really everything top to bottom that can represent your business. And then finally, and I'm hearing this a ton in the field lately, and I'm not sure if you're hearing it as well, I was at an Oracle Oil and Gas Symposium for AI this week. And apparently a lot of the large oil companies are really, really concerned because people who have been running their oil fields and pipelines and refineries for 30 or 40 years are retiring and sort of leaving behind staff that don't have anywhere near that type of enterprise knowledge. And they want to capture that knowledge and deploy it in interesting ways. They're just not really sure how to do so. So another thing that we're doing in our platform from a machine teaching perspective is also bringing in subject matter expertise. We do all of that to create what we call a special purpose intelligence. And the purpose is here to apply application agents to solve particular problems. And I'll go through a couple of those now. Let me bring up another deck. Let's grab that one. All right. So I'll walk through a couple of slides that I think for everyone, there'll be a few disagreements on this, but obviously data makes the world go round. Most projects fail because people aren't able to bring together meaningful data environments. These data environments are ridiculously hard to build. And a lot of the data environments that have been built in the past for this are often SQL-based, siloed, sitting in structured and unstructured data. All of the things we've all heard 73,000 times about how hard it is to build these data domains. We innovated from the ground up. We're not using anyone else's code. We innovated a machine teaching and causal intelligence platform to solve for these problems. There are a number of platforms that are out there that do some of both. We thought that the intersection of both is crucial because the best causal intelligence in the world is useless without meaningful data. And certainly in manufacturing and pharmaceutical environments and others, obviously, the data is so siloed. If you think of modern ERP, MES, APM, and quality systems, these data points sit completely separate. There's actually a really interesting article that I read in the news not too long ago that talked about Samsung's new high-tech chip factory, that they're currently experiencing a 50% failure rate in their factories. I don't know how that data got out of their factory. I'm surprised that it became a news item because they're notoriously very, very secretive. But a 50% failure rate in a chip factory could be directly attributed back to core systems that are operating completely separate and people not understanding the impact of pushing buttons in one or another. What I'm about to talk about, again, is generalized. I'm going to give some specific use cases, but it is generalized and can be used in any environment and used to teach any topic. We on our own have developed an interesting ESG model that's been downloaded a couple of million times. We're working in combination with the UN, and we've built a causal version of that. And I give this example just because it's so completely separate from other vertical use cases we're talking about, and it actually can be added into those use cases as another lever for sustainability and governance. Some of the data sets that we have in that causal ESG data set are child trafficking, child labor, slave labor, et cetera. And those data sets are unique to us in the form that we've got them in. So we've used the platform to teach many, many different things. We're really focused on enterprise decision intelligence as opposed to just domain modeling. We're doing domain modeling with a purpose. There's a reason for building out these causal models. There is a reason for creating AI optimization. All of this can be human in the loop, but we really believe AI is autonomous, and our customers are running these systems in front of core systems in their business. Of course, they've got checks and balances, and everything is fully explainable, but human in the loop introduces problems and slows things down. This slide talks a little bit about how we think about the world and how we go and build out these domains. sort of left to right, you can see here that we start by teaching. I'll just talk about the use case. So this key supply chain use case that we started, our customer had implemented an ERP with SAP. At the time of implementation, and then a couple of $100 million of optimization, their order management platform was 9% autonomous. 91% of orders required hand touching. Most orders required multiple points of intervention to move it through the system. And they wanted to solve this problem. And they came to us to solve for that. And the fact that, as I mentioned with the oil fields, they had 45% of their senior staff and plant managers retiring in 2023. And they wanted to capture those abilities and that knowledge in a system before those people retired. So we trained a system much in the way you would train a college student. We started bringing in supply chain and logistics, textbooks and white papers. We brought in data from McKinsey. We brought in data from other sources, from PhD theses that their employees wrote, and brought that in to basically teach the machine and create a framework, a glossary of supply chain and logistics. We then brought in some models that they'd built already, and then we also brought in large amounts of unstructured data, defining out their problem space, defining their business, some digital twin stuff. We brought in databases that represented all of their customers. Really interesting. This customer sells a lot of product to Costco and Walmart, Target, et cetera. They all have significant penalties when you don't ship on time and in full, OTIF penalties. So we captured all of their contract responsibilities with all of their customers. And of course, this is an ongoing flexible model. So as these contracts change, they're updated in the system. But essentially, we created a digital mirror of their entire supply chain platform from customer through to shipping, including all of their plants, all of their logistics capacity at each one of those plants, and then started processing those orders through a development platform to show them what could be achieved. The customer will say this to you themselves, so this isn't just something that I invented on the fly or exaggerated, but in 65 days, we took their order management platform that was 9% automated, and we took it to 44% automated. In 8 months, we were able to create a production-ready platform that had taken it from 9% to 93%. And today it averages between 95 and 96. And as a new problem comes up that the machine hasn't been taught, they teach that next best action to the machine. Often those next best actions are captured from subject matter experts, in this case, order management experts, who are interviewed. They talk about how they would deal with certain problems. That's captured as a digitized, unstructured data, brought into the platform and brought in with and connected with the rest of the data. So essentially, we're doing causal model teaching with all of those types of attributes that I just talked about. Then we build models that we can run hypotheses against. And for people who are a little bit deeper into AI technology, we use Bayesian models to go and build sometimes thousands of hypotheses against KPIs that you're trying to improve, and come out with the models that have the highest R value to then go and fix those problems. This is fully deterministic. These platforms can be used to build LLMs for different Gen AI projects, but we really are more focused on some of these use cases that I'm talking about right now. What's interesting is the number of combinations that we're creating. When we build the Bayesian models and the hypotheses, it takes a cut of the larger graph model. So it's a relatively small graph. So as it runs through all the hypotheses that it's trying to process based on the question you're asking, it doesn't need to query against billions of rows of data. It's querying against a representative graph for that particular hypothesis. That was sort of the number one use case. I'm actually going to show that really quickly here on this slide. It's use case number 2. It's a little bit older, so this has been improved from 84 to the mid 90s now, and we reduced their service penalty by about 37%. That represented tens of millions of dollars, that particular ROI. And the unexpected benefit from this was their average order processing time was about 3 days. We took it down to 15 seconds. And because they're scored by all of their customers, their supplier score went up, and they drove more revenue from those customers because they were now a more reliable supplier and shipping on time and in full. This same customer, in fact, the lead of this project is mentioned in the left-hand side of this slide. If you're not following him on LinkedIn, he's kind of like the Yoda or Obi-Wan Kenobi for AI. He's super sharp guy, and has been a terrific partner with us in these projects. They saw this incredible capability that was built literally inside a quarter, and they wanted to know what else they could achieve, what other problems they could solve with it. And really what's happened, and I'll talk about the next one, but what's happened is we've probably sped up the digital transformation of this company by a decade, because we've been able to capture attributes of the business that they didn't even think to catch in the first place. 2, we're able to model it incredibly quickly using this machine teaching capability. 3, we're able to train on completely new concepts and ideas that maybe they hadn't thought about fixing or didn't think they had a problem in. So problem number 2, which is listed as number 1 here, is a raw materials and material management, material yield use case. So we had no experience in this space whatsoever. What they wanted to do was take a look at all of the raw materials they use to make paper products, including papyrus pulp, eucalyptus pulp, and hundreds of other raw materials they use to build paper. We taught a machine material science. So we brought in chemistry and physics textbooks, again, white papers and other PhD papers that have been written to teach the machine all about material science. Then we brought in all of the digital mirror of that part of their operation. So all of the SKUs, all of the BOMs, the bill of materials for making all of those products, all of the recipes, the subject matter expertise, and how different machines operate in different parts of the country. They operate very differently in Massachusetts than they operate in South Carolina due to the humidity, for instance. So capturing knowledge into the platform that represented the larger domain of papermaking, their papermaking, and then the subject matter experts' knowledge in building out these products. We were able to very quickly, in fact, I think this was more like 75 days, we were able to reduce the raw material cost. This slide is a bit of an exaggeration, I apologize. We were able to reduce against a $1.2 billion spend. We created an 8% reduction in spend, or a $96 million saving. Second, we then were able to create a sort of a continuous view from APM all the way through to quality. And by reworking some of their recipes, we're able to reduce or increase raw material yield by 15%, which was also many tens of millions of dollars savings for them as well. We're now on our 5th project with them. The 5th one is a health and safety use case, which is very interesting, where they're capturing all of the negative events that have happened over the course of the past decade, I think, and capturing that in a machine, teaching the machine other aspects of manufacturing safety. In a lumber mill and in a paper mill, when there's an accident, it's often fatal. So these are problems they want to have absolute zero accidents or fatalities. So they're looking for the causality between new employees, types of equipment, the types of training they have, time of day that it's happening, the clothes they're wearing, the safety equipment they're wearing, the safety equipment attached to the machine, other potential remediations that they could use to stop people from getting hurt. I'd read recently that SpaceX has had something in the neighborhood of 600 fatalities and serious accidents across their various sites in the past, I think, 3 years. So I'm hearing this use case more and more from customers that we're talking to. I'm going to stop for 1 sec because I just said tons and tons of words and see if anyone has any questions.
Just a little chat going in the chat around the machine teaching process. Sounds a lot like what IBM Watson advocated in 2015. Turned out not to be sustainable. I saw Mark already put some comments back in there, but black box and all the other challenges with that.
Okay, so here, I'm going to stop sharing my screen for a second. We can just talk about it. I can't see the chat box, so I didn't see the question. Sorry. So
that's all right. Mark's catching it too.
So couple of things. One, there isn't a single black box thing about it. So every single piece of data that we teach to the machine, every single decision it makes, you can click on a button. It will show exactly why it made the decision, what the other alternatives were, and then what the source of that data was. So it's very prescriptive in how this is being built. I'm actually not super familiar with what IBM Watson's capabilities were. From what I saw, from where their projects failed, often they failed because they couldn't model data fast enough. They couldn't model the right data. They were building very rigid systems to solve one particular problem that couldn't do, the one step beside it. A good example of this is most Gen AI projects today. There's an article every single day in the news about teaching it a medical textbook, but it can't do any it can't do any reasoning to figure out what disease someone might have. It can answer all the questions on the exam, but it can't then use that data in different ways to answer different questions. It's not particularly good at math or formulas. All things that we're capturing inside our model to your very specific needs for the problem you're trying to solve. And because it's in graph, it's fully deterministic and fully flexible, as you all know, as we're adding in new data types, et cetera, that we think will enrich or help better solve a problem that we're having, and reusable for the next problem.
Absolutely.
I think Michael has his hand up.
Yep. You're muted, Michael.
You're muted, yeah.
Sorry, here we go. So one, I'm just wondering what the difference is between machine teaching, where the machine is taught something, and machine learning. You're using the term teaching very consciously, but it seems to me in both cases the machine is learning something. So what was the focus of that terminology?
I think from our perspective, a couple of things. I think we're bringing in a few sources of data that others are not. So when we're thinking of teaching, what we're doing is using all kinds of different causal methods to create connections between the data, both external and internal and subject matter expert focused, to create new connections in the data, and to essentially teach a particular, the term that Michael Carroll uses is special purpose intelligence, to essentially teach a machine as if it were the most expert employee you have to go do a thing. I think that's the sort of distinction in how we're thinking about it.
Okay, so the machine is learning, but you don't want to use the term machine learning because that implies a whole technology base.
I mean, I guess I feel like I think machine teaching is a superset of that.
Yeah. Anyway, thank
you.
That
doesn't mean I'm right, but that's how I think about it.
No, that's okay. Thank you. The other thing was, how do you? This is a very impressive feat to have all that, to teach the machine all this different stuff. How do you? And you said you're using heavily a graph, but I'm just wondering the broad question: how do you store and organize and integrate all this different kinds of knowledge?
Well, all the first slide that I showed that walked through all the different causal methods that we're using to connect it, et cetera. It's also semi-supervised learning as well. So experts inside the company that are familiar with the subject matter area are given essentially a long list of here's what the machine understands. And as we begin to apply it to problems, the experts are saying, yes, that's correct. Yes, that's correct. No, that's not. Retrain it. And because we can retrain it so quickly, we're using their internal knowledge to make sure that the machine's correct.
Right. Another question was that those performance increases were quite impressive, saving money and reducing percentages and things. What could you say if you put your finger on 2 or 3 key things? What are the main drivers that make that possible? Very significant performance enhancements.
Well, let me talk about the raw material one first, and I think I did, just because that one's the easiest to understand, I think. So when they buy raw materials, their suppliers tell them what the characteristics of their pulp is. That's not necessarily what the actual characteristics are. So they come into their environment and they begin to make paper products with it. And maybe this product that seemed like it was the cheapest is creating a mean time between failure and key equipment, that's twice as negative as it was before. So that raw material is all of a sudden ridiculously expensive. By being able to, along the way, pick better raw material that had less wear and tear on their machinery, that created a better product, that overall created a much lower total ownership cost, was why we were able to find such a meaningful impact there, because they couldn't bring the data together in any other way. And we're running into the largest manufacturers in the world every single day, and they're all set up exactly the same way.
Right.
No one is. Oh, sorry. So that's one. The other one, in terms of the order management, I think that we're again running into environments every day where the order process, the returns process, et cetera, is all highly manual, mostly because the knowledge that exists inside the contracts of the customers, the day-to-day operation of the plants around the country, and then the flow of orders, there's millions of combinations of those things. So having a machine making those decisions for human beings is making a huge difference there for them.
Thank you.
I think Doug's got a question.
Yep, Doug.
Yeah, this is really impressive. Thanks. I wanted to ask, I think this is a little bit of what Michael was getting at in his question, so I'm just going to follow on.
Sure.
We're all the people around the table here, we're a bunch of graph advocates, right? And you mentioned graph very, very briefly, but we also know that a lot of, most of, let's just be honest, most of what machine learning is manipulation of matrices in various forms, right? It's embedding words in and then getting them into floating point number format so that you can have a matrix that works on it. I think the older expert systems, from 20, 30, 40 years ago, they were all about trying to find specific questions and getting specific answers from people. But what they hadn't figured out back then is how to put all of that stuff into matrices and make the computing really cheap, which is what the, machine learning and even, generative AI, all that stuff does. What I think we're sort of interested in is, how do you do this? Like, what's the inner, do you represent your data internally as graphs? Are these like RDF types of graphs, or are you using edges with labeled property graphs with edges where you could do graph analysis on them, or is it something else? Do you
Sure.
want to?
Well,
can you open up the box a little bit and show us how this
hand
how
motion makes me uncomfortable. It makes me feel like we're evil.
Sorry.
So we can output the model in property graph, but why would you? We do all of our development work in RDF, RDF standard. So we probably tested the majority of the leading graphs that are out there, and we obviously worked at a couple of them, including OST and Stardog. Part of it's vectorization. So as we're creating the models, we're creating vectors there as well. So again, from a Gen AI perspective, super helpful for a whole host of use cases. A good example might be we're dealing with a large manufacturer. They have something like 80,000 parts. Those 80,000 parts are represented, unfortunately, not always by the same part numbers, and in about 37 different languages. So by creating vectors across them using a variety of methods, including I just totally forgot the word. I wrote it down earlier. using counterfactors, using counterfactors was the term, using other causal models to basically look through the description of the part, the description of the name, and other attributes about it to figure out this probably looks like this is this. At the end, so we ran through a project like this for a customer where out of the call it 3,800 parts that they wanted to harmonize, 3,500 were accurately matched by us on the very first pass. So then we had their experts go in and verify a couple of others, ran it again, then it was 90%. So that's partly how we do it. Even though it runs in a graph model, what we're doing is setting up these autonomous agents that essentially sit in front of your ERP or MES systems or drug discovery system or whatever it might be, and sends API calls. It basically does the work and then tells the ERP what to do. You don't have to make a single ERP code line change at all because you can't, and it's impossible and it's expensive. So we're doing all of that sitting outside of the machine, running as an autonomous agent. I answered a few questions and even one you didn't ask there.
Good, thank you. Yeah, this is real interesting.
Our customer, Mike and Ron Norris, also from GP, are speaking at the ARC conference in Orlando next week. It's a manufacturing conference, and they're very kind to speak nicely about us. And they also really love their baby. Like what they've built is really special. It's I've been in sales a very, 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 very long time, and I've not seen results like this in any project I've ever worked at before. And as we start to build our sales capability out with Mark and I, and we're out speaking to partners and customers around the world, people are able to talk about their hardest use cases because we can help them solve their hardest use cases, which is super exciting. And when you're solving a problem like we just did for GP, they spent $250 million building that system. $250 million. And for probably about, including, so if we added everything up, they've probably realized about $325 million in ROI. And if you add up all their internal people, all their time, compute, and us and our software, they maybe spent $15 million total to get that 300 and something return. And that's ongoing. That's not one time at all. So just to give you a sense of scope here. So these large projects we're working on, we're fixing in big companies, we're fixing many hundreds of millions of dollars of problems for them.
There's some interesting comments in the chat around,
I didn't have it open. Let me get it.
No, you're right. Yeah. Leadership buy-in and kind of partnering. I mean, I've got to imagine that at each of these engagements, there are people sort of as blockers or challenging what you guys are doing, some of the process innovation kind of stuff. Mark, you mentioned in there, quick POCs is kind of a way of, I mean, have you guys found a few ways to sort of get around some of that? I mean, part of it's got to just be a sponsor with the authority to tell everyone else to be quiet, but.
So it's such an awesome question because, again, those of us in Graph, most of our sales, at least on the old days when we were still proving ourselves, were often a lower level employee who asked permission from their boss if they could work on it on the weekend, and then would go build something and make something happen. So you're absolutely right. I think that couple things. We often start with SVP of strategy and innovation for supply chain, SVP of strategy and innovation for manufacturing. So they've got a list from their CEO and it's probably got 4 things on it. And the CEO's like, go solve these problems for me. So that helps with the question you're asking about. 2, I'll give another really simple, quick use case. Most of our team is in Bangalore in India. And last year over the July 4th weekend, or or as they call it in India, the weekend, someone sent us some data from some data from an oil pipeline. They had 4,000 kilometers of oil pipeline, and when they had a leak, they knew, I forget exactly how wide an area it was, but they knew within like 1,000 kilometers where the leak was. They sent us this data. We built a really quick model, and over the weekend, pinpointed a leak at 1:32 a.m. on April the 23rd. And we were able to identify between two pumping stations, which was something like, I think, a 10-kilometer run. So we were able to identify it, day part and where, so that they could go fix that. I don't know if you're aware, but there's a regulation called I think it's called Colorado 7. And it basically says if you run pipeline anywhere in the United States and there's a leak, you'll have it fixed within 7 days, or the fine is going to be really, really painful. Obviously, not everything is a leak like we saw in the Gulf of Mexico off of Florida with I think that was BP. There's all kinds of minor leaks like that that are happening all the time. And we were able to do essentially we did a free POC for them over the weekend to show them that we could do it.
That's great. Michael.
Yeah, so you're using graphs in RDF, which means you have some kind of ontologies or schema with the properties and classes. Just wondering what process, are you building those automatically from text, or are you spending a lot of time manually constructing these ontologies?
There's no way we could and do it in the speed that we're talking about, I think, as you can imagine. So when we start with source material, whatever that source material would be, there's some customers that do have some basic ontologies built out already. We can use those as a starting point. For some customers, it's the domain data, right? It's all the glossary that comes with the chemistry of making paper, the supply chain and logistics world, and all of that sort of glossary. So we're building off of those core points. We're also pulling in data from, whatever the source might be, call it SQL tables, for instance. We're bringing in some data, metadata from those SQL tables themselves. So we're using all those sources to build out the core framework of these models.
Thank you.
And the first iteration is always completely without human intervention. So, I mean, we were just talking about on a previous call, with another use case, and within the first iteration, which was just done by the computers, was 80%, modeled from.
There's still some human intervention. That's not totally true, but it's close to true.
Yeah.
I would say limited human intervention.
Yeah.
Come on, Mark.
Limited. Yeah.
You just put all of us out of work. Slow down, mister.
Yeah, no, but there is the human involvement comes down in the refinement of the model. So as you refine the model down, then you're constantly having to check against, the balances that you've got. Is this correct? Is this correct? Yes, 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 yes. No, no, no. And the model gets refined from there.
And what techniques are you using to automatically build these ontologies?
To be honest, it's probably like a level past. I'm pretty knowledgeable. It's probably a level past. I'd be more than happy to get one of our core team on the phone to talk more about that. I think the slide that I showed first talked about some of that. Let me just bring that up again, and we'll see if we've got some answers there for your question.
Okay, thank you. This might be that this field has advanced. My understanding is that it does a pretty good job some of the time, but it requires a lot of human intervention. So maybe that's changed now, which is good to know.
I think like one thing that I would point out is that we're not trying to, let's see. So I'd say the first two boxes here talk about some of the methods that we're using to go and build this. One of the first use cases we focused on was with Dow Jones. Dow Jones was trying to sell to their wealth management, their wealthiest clients, like an alpha product that was looking for alpha in news stories. And we needed to use causal inference to understand in one story, Apple and Samsung would be a competitor. In the next, they would be litigants. In the next, they would be partners. In the next, they would be co-inventors. Who knows, right? But we essentially had to build out an a causal inferencing capability that would let us do that type of work. It's those types of capabilities that are helping us to build out the corpus of these domains. And I'm happy to get I'm happy to do a separate session if you wanted to do something separately to dig in deeper with the guys who invented it.
And all that causal knowledge and all the other kind of knowledge is sitting in the graph.
Correct.
Cool.
And in people's heads, and we extract it.
Exactly.
In pleasant ways.
That's right. Not a Neuralink chip.
not a Neuralink, exactly.
Not yet.
Doug,
did you have a question?
Yeah, that's what I thought.
I was just gonna, yeah, well, I was, again, sort of following up on Michael's question. We were wondering if there's, do you use a formal top-level ontology as a starting point for this?
Hey, did you say, can you?
No. Well, do you?
No.
Okay.
I'm not sure. Maybe I don't understand your question.
Well, when we go into we use GIST. We have our upper level ontology here at Semantic Arts that we develop ourselves, but we use that as a starting point at customer jobs because it, a lot of times it does GIST alone will do 70 or 80% of the work. You've got all the top level classes you need, the disjoints, you've got lots of useful properties and things like that. It just makes things go much, much, much faster. And I'm just sort of wondering,
we can use
do you build the whole thing up from scratch every single time by sucking in lots of data and then,
it varies.
Or do you try to make it
no, the answer is yes. The answer is yes.
But it varies from use case. We can use, if you've created an upper ontology, we can use that.
Correct. I mean, we could. So the fact is we're using whatever source material the customer has and general domain knowledge. I remember once we worked on a use case for insurance companies where they wanted to understand the different impedances by state here in the United States. And one of those was tribal land and tribal treaties. And that was something we captured from the general internet. But so when we built out the model, we basically started with their own insurance framework that they had that had sort of a glossary of terms and a basic structure. But each use case is specific to itself.
So one other question that comes to mind is I'm looking through looking at your examples, which I find really interesting because it's rare that we see stuff that's straight out of the manufacturing domain or, tied to, paper mills and stuff like that.
I have lots of oil and gas ones too, if you want to hear those.
Yeah, well, no, but what I find interesting about paper is that, I mean, there's a lot of chemistry involved. And, if you take models and if you just point them at the internet and just say, go figure out the chemistry based on the internet, might not be that easy. But you said you're taking textbooks, you're taking PhD theses. It is theses, by the way.
I thought it
was. And you're using that it sounds like to create a physics-based. There has to be basically a physics-based model. If you're going to make decisions, expensive purchasing decisions, you want to make sure you've got the chemistry right. I assume. And so. Are those models that the models of the science into the physics, again, are those just spun up from the mist as you start to ingest data early on in a project? Or do you,
from the mist is uncomfortable and you're doing this thing again. I think that
well, I know. Sorry about that. I should turn off my camera when I ask questions.
I'm just kidding, Doug. Come on. After some PowerPoints, we need some jokes. So I know that we bring in equations. I know that they're part of the model. I don't know specifically how we do that. We don't spin it up from nothing. Like obviously all of these companies, as they're teaching their own internal employees, have all their own internal sourcing and documents and processes, right? So all of those materials exist completely separate from the daily data of what they're doing. This is larger domain data that they've got I remember being in Verizon years ago, and they had all the books written by their PhDs downstairs. You know, that's one of the sources. They would just start to process in those digitized books, to start to create an ontology for them. Can I answer Jonathan's question really quickly, just because I love talking to Jonathan?
Yep.
Sure.
Jonathan, nice to meet you.
Yeah, nice to meet you.
So that's a risk and regulation use case where essentially, I forget if it was BCBS 239 or not, but across a multitude of regulatory compliance requirements, we were able to contrast that or compare that against what they had accomplished internally and what % complete they were against that goal and what else they needed to do. And then, of course, as new regulations came out, the ability to be constantly updating that regulatory special purpose intelligence to contrast against their internal compliance.
Great. Okay. Thank you.
And again, like I'm giving, sorry, Mark, I'm giving some very specific examples, but it really is, it is a generalized capability. It's just obviously it's not inexpensive, so you want to point it against really challenging problems. But when I was working with Citi a few years ago, I'm pretty sure they got a $400 million fine for not being in compliance with that. This is cheaper than that. A lot cheaper than that.
Much. And have you done any work with data catalogs, or is that too simple a problem to solve?
That's such an interesting question, because I just got kind of an itchy some hives remembering some data catalog problems back from the day. From a data management perspective, I just think of catalogs as being another data source. If you wanted to sort of reverse that around and say, hey, could we use this capability to better define our data and create, populate a data catalog? The answer is yes. I just don't think that it's a big enough problem, but maybe I'm wrong.
Yeah, we can, if you tell us about the specifics around it, we can certainly look at it.
Okay.
Yeah, it'd be interesting to look and see what they're trying to solve. I mean, it really does depend. I mean, we just come off another call where they were talking about matching terms across ERP systems, because they've got the same products in the different ERP systems, and they need to match terms across those systems and link those systems to be able to answer the questions they need to, and they haven't been able to solve it. They've tried every way. They've tried using standard graph, everything, and they've not been able to solve the problem. So it depends on the use case, depends on the challenge, but we'll certainly look at it.
Alan had asked a question a while back about why more AI companies aren't talking about agents to manage back and forth data flow. I think because everyone is talking nonstop about Gen AI for some reason, which I'm not really sure why.
It's okay. Which is great for vector search.
I don't know the answer. I mean, all I know is, to be 100% transparent, I don't think we really knew what we did until a customer showed us what was possible. We were focused on doing a lot of data catalog, rough data domain mapping work. And before anyone was using graph, trying to convince people we had a faster way to build graphs didn't seem all that interesting to people. It was interesting. Like, I think all of us probably know Mike Aiken might be the Kevin Bacon 6 degrees of separation for everyone in the entire market. And we all know all of those people. So obviously the world is very different today, thankfully. And people see obviously the opportunity to use fit for purpose use cases against graph, because graph is fantastic for the right use case. I don't want to run my ATM network on it, but it's terrific for a bunch of other use cases.
Did you know Mike is with Semantic Arts now?
Yeah.
I think that's how we got hooked up originally. It was Mike.
I thought he was on the call. Is he not on the call?
He's not today. Nope.
What a jerk.
I know. I'll be sure to pass that along to him.
Other questions? I can talk about a few more use cases if it's helpful, or we can also give you a half hour back. It's up to you.
We got 7 minutes more. What do you guys see? I know you mentioned sort of the partnership model, building out kind of partnerships and implementations. What else is on the kind of 1 year, 3 year, obviously more great use cases, but do you guys have some specific targets or things you're looking to do here?
So I think we are, we started off in financial services, so we've got some good use cases there. I'm actually really excited by the concept of just the ridiculous amount of contracts and regulations and just all that paperwork and what can be accomplished, working through all of that to create meaningful models to solve real problems. I'm excited in creating engines that, as your bank has different levels of risk, do we want to loan to Donald Trump or not loan to Donald Trump? I think he needs about $93 million. That you've got an engine that actually can be adapted to your exact current sense of risk and be able to build domains of these people that you're looking at risk models for, maybe deeper than you would be otherwise. I'm really interested in fraud use cases. So I think the answer to your question is across 2 or 3, 4 verticals. So financial services, pharmaceutical, manufacturing, oil and gas, just to really go deep to solve some of the most challenging problems that they have. I was on the phone a couple days ago with a large chemical company. They make polyethylene. It's a $16 billion polyethylene company, and they don't have any storage facilities. They store everything in railway tankers, and they logistically they make 200 types of polyethylene, and not every railway car is appropriate for every type of polyethylene. So it becomes the traveling salesman AI problem where they need to store it. They need to put the trains together in a way that can go to every single corner of the United States, and then, of course, go to tankers to go in ships as well. And I asked them what platform they were using to do this. This is an incredibly complex set of decision making. Guess what system they use?
Excel.
His name's Bill. It's a guy. He does it all manually. So it's like a really, I would never think in a million years to ask about that, like absolutely core to their business. They need an armed guard around that guy and bubble wrap literally 24/7. But it's a good example of something I wouldn't even thought to ask about. That's a really, really exciting use case there. And we run into them every day. A medical device company that has 8,000 or 9,000 customers, each one seemingly with a different RMA allowance in their contract. So every single return is done by hand by a team of 30 or 40 people. It probably costs them 30 to $40 million a year in just manual intervention to do the work. And then the amount of mistakes that are being made must be crazy. And that's like an excellent use case for a special purpose intelligence to codify all of those contracts with those customers and contrast that with whatever they're trying to ship back and whether or not they're allowed to.
Michael,
I think the other answer to your question, JT, is create more tooling so that partners like Semantic Arts can more easily use the platform, even though I think it's pretty usable already, but just build out that capability because mostly we've been just doing it ourselves. But we don't want to do it ourselves anymore. We definitely want to branch out and be able to use you guys.
Michael, did you have your hand up or put it down intentionally?
Yeah. Coming back to this ontology question. So you said that if you did have an upper level ontology, you could make use of it. So you went into a manufacturing company and you kind of did your automatic, semi-automated, well, mostly automated and human curated certain things. And now you have manufacturing company number one ontology for it. Now you walk down, now life goes by and you have another manufacturing company. Now you could start from scratch and do the same thing over again, or you could extract out the commonality of the manufacturing industry and reuse it. So I guess like you're not doing that kind of reuse.
I think that I'll let any company that's on the phone call here speak for themselves, but I just think people get so uncomfortable with the concept that we would take anything that they felt like might be their own proprietary data. And of course, what you're describing is not. I just think people would be super, super uncomfortable. So
I see what you're saying.
We may have sources. So imagine, I don't know, the telephone book is the greatest source for building a manufacturing ontology ever. And that's public use. We'll just use the telephone book next time too. So that's one of the answers to your question, that we did build out kind of a library of external resources that are not proprietary that we'll absolutely use in a manufacturing environment or material science environment next time, to the extent that it's applicable to the use case.
Sure. Cool, thank you.
Peter?
Peter.
Looks like you get the last one.
So, I mean, following on from that, can you use these, as Michael was mentioning, maybe to model the counterfactuals? Because sometimes people can't imagine the possible ways in which things might not go according to plan.
That's an interesting question. So we just worked on a project with Honeywell, and I think we're actually going to partner with Honeywell with one of their products. They do predictive maintenance, and anyone who's an AI person on the phone understands mostly that predictive maintenance is Excel extrapolation. And they're really interested in, no offense meant, but it's true. And that's useful and helpful too. But often large machines that have got IoT sensors on them are failing because of other parts in this case in the pipeline, in the refinery refining process, that don't have sensors on them, that are slowly breaking down, causing those more expensive larger machines to break down and creating a cycle time that's lower than it should be. So we did some work to prove that we could find novel faults in systems because of the causal nature of the data that we were capturing. It was part of that pipeline use case as well. Essentially, we're able to look at data in a different way and find problems they didn't even know that they had in the first place. It still existed in the data. It's not like we can find something that's invisible. It still existed in the data. They just didn't have it in a format before that they could do that analysis.
So then
I hope that answers the question.
Yeah, so the secret sauce is in making connections across existing corpuses or whatever, corpi, whatever they are in the plural, that are very hard to do by any other normal means we have, right?
Correct. And also adding in literally the knowledge of your like, I heard FBI is about to move to Huntsville, Alabama, and probably most of the senior staff that have lived in Washington, D.C. their whole lives and have lives and children here and everything else aren't going to move to Alabama and aren't going to be part of the FBI anymore. It's scary as someone who lives in this country to think that 40% of the people that know how the country works and where the bad guys aren't going to be there anymore. So thinking about building an ontology that captures all of the knowledge they have about biker gangs and drug cartels and like all the bad guys, and then all of their own knowledge about what's really a threat and what isn't a threat, and what are a combination of things we see. This plus social media plus an email means there's an attack, whatever. But all of that knowledge walking out the door is scary. So that's the other part of this that I think that's special, that shouldn't be lost, that all the data in the world is made so much more powerful by application and knowledge, application and expertise.
That's great. Well, very good. I think we'll call it there. I put LinkedIn contact info for Mark and Jonathan in the chat there, Parable's website. If you guys, I will email this recording out here later today. So if you want me to include specific contact info, slides, any of that, if you want to just send it over to me, I'll make sure that goes out to everybody as well. And then Jonathan mentioned a follow-up call. So anyway, thanks everybody for joining here. Sorry, I'm going to check the chat. Yep, thanks for sharing. Really appreciate it. And we'll see everybody here next month, I guess.
We really enjoyed the conversation. Thanks, everybody.
Yeah, thank you.
Yeah, thank you.
Thank you very much.
Cheers.